This video will provide an overview of key concepts included in Chapter 18, Lean Operating Systems. Lean thinking is playing a large role in making supply chains more efficient and sustainable and helps drive a culture of waste elimination. Lean thinking refers to approaches that focus on the elimination of waste in all forms and smooth, efficient flow of materials and information throughout the value chain to obtain faster customer response, higher quality, and lower costs. Manufacturing and service operations that apply the principles of lean enterprise are often called lean operating systems. There are four key principles of lean operating systems. First, there's elimination of waste. Now, any activity, material, or operation that does not add value in an organization is considered waste. Toyota has identified 7 major categories of waste, which include overproduction. Overproduction ties up production facilities, and the resulting excess inventory simply sits idle. There's waiting time. For instance, allowing queues to build up between operations results in longer lead times and more work in process. A third source of waste is transportation, which is the time and effort spent in moving products around the factory as a result of poor layout. Another waste is processing. This is the traditional form of waste as exemplified by scrap that often results from poor product or process design. There's inventory, which is waste associated with the expense of idle stock and extra storage and handling requirements needed to maintain it. Another waste is motion that results from inefficient workplace design and locations of tools and materials. And finally, there's production defects, which is simply the result of not performing work correctly the first time. Here's a common list of examples of waste in organizations that include clutter, scrap, accidents, spoilage, and misrouting jobs, among many others. The second principle of lean operating systems is increased speed and response. Lean operating systems focus on quick and efficient response in designing and getting goods and services to market, producing to customer demand and delivery requirements, responding to competitors' actions, collecting payments, and addressing customer inquiries or problems. The third principle is improving quality. Poor quality, whatever the source, disrupts work schedules and reduces yields, requiring extra inventory, processing time, and space for scrap and parts waiting for rework. Eliminating the sources of defects and errors in all processes in the value chain greatly improves speed, reduces variability, and supports the notion of continuous flow. The fourth lean operating system principle is reduce cost. Anything that's done to reduce waste and improve quality often reduces costs at the same time. More efficient equipment, better preventative maintenance, and smaller inventories reduce costs in manufacturing firms. Meeting the objectives of lean enterprise requires disciplined approaches for designing and improving processes. Organizations use several tools and approaches to create a lean organization. They include the 5 S's, which is derived from Japanese terms pertaining to sort, set in order, shine, standardize, and sustain. Another tool is the use of visual controls, which are indicators for operating activities that are in plain sight of all employees so everyone can quickly and easily understand the status and performance of the work system. A third tool is single-minute exchange of dies, which refers to the quick setup or changeover of tooling and fixtures in the processes so that multiple products and smaller batches can be run on the same equipment. Fourth, there's batching and single-piece flow. Batching refers to the process of producing large quantities of items as a group before they're transferred to the next operation. Single-piece flow, on the other hand, is the concept of ideally using batch sizes of 1. A fifth tool is quality and continuous improvement, which is mainly about building quality in at the source and requires doing it right the first time, therefore eliminating opportunities for waste. Employees inspect and analyze their own work to guarantee that the good or service passed on to the next stage conforms to specifications. Continuous improvement initiatives are vital in lean environments, as is teamwork among all managers and employees. The last tool is total productive maintenance, which focuses on ensuring that operation systems will perform their intended function reliably. Lean production forms the basis of what we can call a just-in-time system, or JIT, or JIT, which was introduced at Toyota during the 1950s and 60s to address the challenge of coordinating successive production activities. Traditional factories use a push system, which produces finished goods inventory in advance of customer demand using a forecast of sales. Parts and subassembly are pushed through the operating system on a predefined schedule that is independent of actual customer demand. Now, this kind of system didn't make sense for Toyota, and so they created a system based on a simple idea: produce the needed quantity of required parts each day. This concept characterizes a pull system in which employees at a given operation go to the source of required parts, such as machining or subassembly, and withdraw the units they need. Then just enough new parts are manufactured or procured to replace those withdrawn. As the process from which parts were withdrawn replenishes the item it transferred out, it draws on the output of the preceding process and so on. Finished goods are made to coincide with the actual rate of demand, resulting in minimal inventories and maximum responsiveness. Just-in-time systems are based on the pull system. Many just-in-time systems rely on something called a Kanban. A Kanban is a flag or piece of paper that contains all the relevant information for an order that can include part number, description, process area, time of delivery, quantity, etc. The Kanban system is similar to a bin system where an empty bin or Kanban triggers the replacement from all supporting activities. For example, an order from a customer creates an empty bin to be filled by a product which may come from a warehouse. Once the warehouse bin is empty, that triggers fulfillment from production, and so forth, backwards through the production process and through various workstations. Time systems produce according to the rate of sales. The takt time is the production rate for one good or service based on the rate of sales. Takt time is a term widely used in lean operating systems and value stream mapping. Here are some examples of just-in-time characteristics and best practices that include mistake proofing, using reusable containers, good calibration of equipment, and empowered employees, among many others. Just-in-time lean systems can be compared to Six Sigma and the theory of constraints, both of which were covered in previous chapters. In terms of focus, lean thinking emphasizes reducing waste. Six Sigma focuses on reducing variation and elimination of defects and errors, and the theory of constraints focuses on maximizing throughput and cash flow. With respect to tools and methods, lean thinking uses the 5 S's, continuous improvement, etc., while Six Sigma relies on cost of quality, statistical process control, and quality standards. The theory of constraints relies on value stream maps, financial metrics, and bottleneck management. Each approach has its own set of goals and benefits. Lean thinking seeks to improve process flow, reduce variation, and smaller inventory requirements. Six Sigma seeks to lower cost, increase yields, and customer satisfaction. The theory of constraints helps improve process flow, reduce waste, and improve quality. All approaches, however, can benefit from higher productivity. Lean operating systems can apply to both manufacturing and service operations and have universal appeal. Regardless of the type of operation, seeking to eliminate waste, increase speed and response, improve quality, and reduce cost only makes good business sense.